Hi, I'm Dennis Hudson with the Hudson Equilibrator, U.S. patent number 8591449B2. And I'd like first of all to thank you for taking the time to watch this little video, and I believe it's going to be well worth your while. Alright, first off, licenses are issued according to field of use. And you can get more information about licensing at the website there, whattolearn.com/license.htm. And there's also a short video on that same site where you can see a video of how the license works. It's a very novel approach to licensing. I try to make it scalable so that you have a chance to evaluate without expending a great deal of capital to do so. Now, it's really difficult to make a single video about a seminal invention, and that's what this would be called because it has such a broad range of application. But I've done the best I could do in a reasonable length of video. And at that same website there are links to more in-depth information about particular fields of use. Briefly, however, here is as I say, the short list of fields of use. As you can see, it can be used for energy storage or storage of excess energy. I'm actually going to put the device together right before your eyes, so bear with me, please. You can store excess energy or use it for emergency energy. You could actually plug it into the wall if someone doesn't have solar or wind or geothermal or something, and they just store it up and the energy is there when they need it. Medical applications for IV drug delivery, you get rid of the pole, the IV stand. You can actually dispense with the drip portion of it. And in cardiopulmonary bypass equipment, extracorporeal circulation, aerospace, the suspension systems, and fuel systems. That would also apply to fueling rocket motors, where you would combine, as you'll see, you'd be able to combine an oxidizer and a fuel into a single fuel pump. Automotive, suspension systems, emergency starting, toys, you can see what's there. Marine applications, silent running submersibles, so you don't scare off the local fauna. Education, teaching devices, research. So, it's very broad, and that's just the short list. Now, just to orient the viewer, when we come to the schematic, because I'm going to assemble this from a very simple schematic, but to orient the viewer, what we have here is a housing. The top in this lower view is removed, so we're looking down inside of it. Along this wall is a groove, and there is a tongue. This right here, these two pieces right here, that's a partition. They are slidably interlocked, tongue and groove. There is a tongue on one end that fits into the groove on this wall, a tongue on the end of this one that fits into the groove on this wall. This here is a spring that we'll be talking about, and this is a flexible bag that contains hydraulic fluid, and over here we have a valve. Okay, so this will kind of orient you to what you're looking at. Now, there will be one slight variance from what I'm going to be showing you, and that's that the tip of that triangle is going to be truncated, and it's going to be truncated right about there on that line there, and that's to allow complete expulsion of the hydraulic fluid on discharge of the energy. And the truncated version is, of course, expressed indirectly in the claims by describing this front portion as a front portion. It does not actually describe that it comes to a point or anything like that. And you can actually see a truncated version in one of the drawings. This is one of the official drawings. This happens to be an automotive emergency starting system, and you can see how that triangular shape is truncated right here. Alright, I promised to show you how to assemble the device. It's very simple, it's very economical to fabricate, and let's get started with that. First thing, we want to put the spring in place. Remember where the spring was on that other one, the official drawing. Next, you're going to place the flexible, substantially non-permeable plastic bag that has some hydraulic fluid in it now, as you see. And then we're going to put in part of the partition. Remember, these two parts here, these two red parts, are slidably interlocked. And we'll just set that right there, and they're slidably interlocked with the sides of the housing. So we'll place these where they belong, and finally we put the valve in place up here, like so. Now I should point out at this point, before I forget, claim 13 here, the reason that that's appearing, whoops, that's not what I wanted to draw. Let me take that off right quick. The reason that that's noted here, claim 13, is because claims 1 through 12 involve a very boxy, complex version of the invention. This is the simplest embodiment. Your license would cover you to use the boxier embodiments in your field of use as well. Now, in operation, as you introduce fluid through this valve and the valve is connected to the plastic bag, as you introduce hydraulic fluid in through here, you force the partition upward, and the partition actually opens up. It spreads further and further apart as you compress the spring. Or you could externalize the spring, that's covered in the patent as well. And in which case maybe you would actually want to have a spring that instead of it's being compressed, you want to stretch it out. It works the same either way. Now what's important here is that as you fill the bag and it pushes the partition upward and compressing the spring, your static pressure in the hydraulic fluid remains the same. So even from full compression all the way until it's completely exhausted, when you expel the fluid, you have a constant dynamic and static pressure throughout that process. And that's because the stress in the hydraulic fluid is moving in step with the increasing stress in the spring due to the fact that the partition is expanding and you have a greater surface area acting upon the spring, and also it's acting upon the hydraulic fluid. So at the storage end of the process, you end up with a picture something like this. And when you're ready to release the fluid, you open the valve and the fluid will come out at a constant rate of flow throughout the dispensing process. Now, it's probably already occurred to you that using a bag of air instead of a physical or mechanical spring, that is, instead of a metal or plastic spring, using a bag of air instead would be a cheaper way to go, but this is a complex thing to do, and I'll show you why. Okay, here we are. We have a volume of air contained within a cylinder that is attached to the housing, or you could actually have the volume of air down here in this space here inside a bag itself. The problem with either approach is that the expansion of the partition is a linear function, whereas the compression of the air is any gas is according to Boyle's law, and that's an hyperbolic function. And the specification of the patent states that these have to move in step with one another, so that would not be feasible with this arrangement. However, since the patent doesn't describe a particular shape, a triangular shape, it just says a front portion, a left and right, rear, top, and bottom portion, what you can do is modify the geometry of the housing. And that might look something like this. Instead of a straight wall, as you see here, what we might do is have a wall that assumes a shape something perhaps closer to that on both sides. In other words, what you're trying to do is accommodate this rapidly increasing air pressure with a rapidly increasing platform, partition. So you can see from this, there's lots of room for innovation from your technology department. I won't go into the details of the exact nature of the curves that might be required. It would vary according to how you set this up. And as well, another serious consideration would be the rate or the speed with which that air is compressed, as well as the frequency of charging and discharging the hydraulic fluid. In other words, we've got thermal hysteresis going on, and so this curve right here would have to accommodate that as well. So that concludes my presentation. I'd like to thank you again for taking the time to watch this video. If you need to reach me directly, there's a contact link on the website, or I'm listed in the phone book in Albuquerque, New Mexico. Just give me a call. That would be my residence you'd be reaching me at. Thank you again.